Every script we built so far runs the exact same way, every single time. Same task printed the same way, same schedule generated the same way. But real data isn't that predictable. Sometimes a value needs different treatment than another. Today, we teach Python to make decisions. Here's the simplest version of a decision in Python, an if statement. If the score is greater than or equal to 90, print A. If the condition is true, the indented code underneath runs. If it's false, Python skips it entirely and moves on. Let's see what happens when the condition is false. Nothing happened, and that's correct. The condition was false, so Python had nothing to do. If we want a fallback for when the condition doesn't hold, that's what else is for. Now every score lands somewhere, either the if branch or the else branch. But real grading isn't just pass or fail at one cutoff. There are several grade bands. That's where Elif comes in, short for else if. Python checks each condition top to bottom and stops at the first one that's true. 78 fails the first check, fails the second, passes the third. C prints, and Python never even looks at the else. Order matters here. These conditions have to go from highest to lowest, or a 95 would get caught by an early loser check. A quick note on comparisons. Since they're the backbone of every condition, double equals checks if two things are equal, not equal to checks if they're not equal, greater or equal, and less or equal. These work the same way on numbers, strings, even booleans. Notice that second one, Jordan and Jordan, are not equal, because Python treats these uppercase and lowercase letters as different characters. That's exactly why we covered the lower parentheses and upper parentheses back in episode 3. They're often used right alongside conditionals for this exact reason. One more thing worth knowing. Conditions can be nested inside each other, when you need to check something only after another condition is already true. Nesting is fine in moderation. One condition inside another is completely normal. Just be careful about nesting too many levels deep. If you find yourself 4 or 5 if statements in, it's usually a sign to break the logic into smaller pieces. We've now got if, elif, else, comparisons, and nesting. Enough to build something that actually reacts to real data, instead of just processing it the same way every time. Let's put it to work and build a full grade calculator. This script is going to take a source and return a full letter grade using everything we just covered. Full code is in grade_calculator.py. Here's the core logic. Same script, 3 completely different outcomes, because it's actually looking at the data and deciding what to do with it. That's the shift conditionals bring. Your code stops just running top to bottom and starts branching based on what it actually sees. Quick recap. If runs code when a condition is true, else covers everything else, elif checks additional conditions in order, top to bottom. Comparisons like double equals, not equal, greater than or equal, and less than or equal are what those conditions are built from. And nesting lets you check a condition only after another one already passed. Our grade calculator works great for one score at a time. But what happens when you got the same logic needed in 5 different places in your script? Right now, you'd be copy-pasting the whole if, elif block over and over. And the second you need to fix something, you'd have to fix it in 5 places at once. Next episode, we solve that permanently. Functions. Write the logic once, give it a name, and call it from anywhere in your script as many times as you want. See you in episode 7.